Okay, so when talking about combining like terms, there's some important terminology that you guys need to know. So I'm going to write down an expression here, and we're going to label some important parts of the expression, okay? So here's the expression. Write this down. We're not going to do anything with it. We're just using it as an example to label some parts, okay? All right, so in that expression, we have things called terms, okay? So for example, 5x, that's called a term. Positive 4y, that's a term. Negative 2x, that's a term. What else is a term? 6y. What else is a term? 15. So how many terms are in this expression? 5. Okay, each of these is what we call a term. Okay. Now, within the term can be made up of different things. Okay. This particular term has a letter, not just a number. Do you guys remember the mathematical word for letter? I heard someone say it. Variable. Do you guys remember learning that word before? Okay. Let's define what variable means. Why do we use variables? Yes? Yeah, we're trying to find a missing number, right? So a variable is just a letter that takes the place or it represents an unknown number. Maybe a number that eventually we want to know. Okay? So it is a letter that takes the place of a number. So in this expression, we have a couple different variables, right? We have x's and we have what else? Y's, okay? Now, we also, in this expression, have some numbers, okay? And there are some numbers in front of each of these variables. Now, those numbers have a specific name. Do you guys remember what those numbers in front of the variables are called? What the name we give them is? I'll give you a hint. It starts with the word co-efficient. I heard someone say it. Yes, coefficient, okay? So, each of those numbers that's in front of the variable, those are called a coefficient. So, for example, -2 is a coefficient. What is the coefficient of this term? 6. What's the coefficient here? 4. What's the coefficient here? 5, right? Okay, so the coefficient, this is the number that is multiplying by the variable. Okay, it's usually in front of the variable. Every now and then, if it's a fractional number, it'll be underneath the variable. But most of the time, if it's non-fractional, it's in front. Okay? Now, each of these numbers is multiplying by the unknown number, right? 5 times some number, 4 times a number, -2 times a number, 6 times a number. Okay? All right, now, what about this number over here? Is this called a coefficient?
No.
No, this one doesn't have a variable that it goes with. So there's a different word that we call this kind of number. Does anyone remember? Whole. This one is a whole number because it's positive. But specifically, we're going to call it a constant. Do you guys remember learning that before? Yeah? Okay. So a constant. All right? So 15 is what we call the constant. The reason why we call it the constant is because no matter the value of x or y in this expression, this number stays the same, right? When x changes, 5 times x changes its quantity, right? When y changes, 4 times y changes its amount. But if x or y changes, 15 doesn't change. It's still the same, right? Okay, so a constant is like the regular number without a variable. Okay, now when we're combining like terms today, we need to understand what like terms are. Okay, so before we write a definition of like terms, I'm going to show you guys some terms, and you're going to tell me whether you think they are like terms or not, and we're going to discuss then after that what we think the definition should be. Okay, so let's take a look at these two terms. Are these alike? What way are they alike? They have an x. What way are they not alike? One's negative, one's positive, right? Okay, so these two terms do have an x in common, right? Do they have more in common than these two terms? Okay. Are these two terms having the same variable? No. Okay. So the difference between like terms and unlike terms is like terms have to have the same variable. Okay? So these two terms are alike because they have the same variable. Even though one's positive and one's negative, we still consider these like terms because they have the same variable. Okay? These two, even though they're both positive, they're not like terms. Why?
Because they don't have the same variable.
Yeah, they do not have the same variable. Okay? So the sign, like positive, negative, doesn't matter when we're considering whether they're like or not. What we're looking at is the variable. Okay? Now, take a look at these two. Are they alike? Why? Yeah, one is missing a variable, one has one. These are not considered like terms. One's a constant, one is not, right? Okay, so not like terms. Okay, what about these? Do either of them have a variable? No. So they're actually considered like because they both are missing a variable, right? Two constants. Both of these numbers are constant. They are like. Okay? What about this one? You guys are like, kind of. Do they have the exact same variables? No. One has x, one has xy. So these ones, not alike. Okay? What about this one? What variables do they have? Yeah, so are they alike? Yes. Okay. Now, what about this one? Are we not sure? Okay. So, this one is just an x, right? What does x squared mean? X times x, right? So this one has 1x as its variable. This one has x times x as its variable. That's not considered like. Okay? The way you can also tell is you can look at the exponent. If the exponent on the variable is different, they're not considered like terms. This is like x, this is like xx. Does that make sense to you guys? Okay. What about these two? Why are they alike? Yeah, they both have same variable, same exponent. Okay? So, in order to be considered like terms, okay, the terms must have the same variable or variables, right? If they have like multiple, right? with the same exponent. And so in some cases, that means they're the same if they both have no variable, right? Now, when we're combining like terms, we can only combine the ones that are alike. We can't combine different kinds. Okay? So we're going to do some examples. Here's your first example. And I want you guys in this example to think about which terms are the same kind. You have 15a, 7b, negative 10a, positive 2b. Okay? Which ones are the same kinds? You really only have two different kinds, right? What are they? A's or B's, right? So what I can do is I can combine the A's together. So I can actually rewrite and reorder this so I put the A's with each other. Then I can take the terms with B's in them and put those next to each other. I'll put them over here. Then what I can do is combine the ones that are alike. So, what's 15 take away 10?
5.
Okay. And what's 7 plus 2?
9.
Okay. When you are combining like terms is similar to like going grocery shopping. How many of you guys have been grocery shopping before? Okay. So, let's say you go grocery shopping. Your mom puts 15 apples in the cart. She then puts 7 bananas in the cart. She then changes her mind, says, no, go put 10 of the apples back. So she sends you back to put 10 apples back. And then she says, no, but we need 2 more bananas. So you get 2 more bananas. What's in your grocery cart? You started with 15 apples. You put 10 away. How many are left? 5 apples, right? Did the apples, once you put some back, did they like magically turn into apples squared? No, they're still apples, right? Okay, so the variable doesn't change when we combine our like terms, all right? Also, you had 7 bananas in the cart. She told you to go get 2 more. Now you have 9 bananas. Did they change into bananas squared? No. Now, once you have your 5 apples and your 9 bananas, do they combine into apple bananas or banana apples? No. It would be cool if they did, but they don't, right? So what a lot of students want to do at this end part is they really, really, really want to write for their answer 14AB. Wrong. Okay? This is not 14AB. You still have apples in the cart and bananas in the cart. They're not apple bananas or apple nanas or banana apple or bapple or whatever you want to make them into. Okay? They're not. All right? Are we all understanding that when you get to the end, if they're different, you can't put them together? Okay? Are we good with that? Okay. All right. So let's try. I'm going to have you guys try an example right now. Okay? You guys try this one. Okay, so which ones could go together?
6 and 8R, negative 8R, positive 7R, and 4AB.
Okay, so you got some M's, right?
Yeah.
Those can pair up. What else do you have?
7R,
Yeah, R's. And then what else can pair up? Yeah, 12 and negative 8, okay? So, I'm going to rewrite some of these things next to each other. Negative 4m can pair with 6m. Then positive 7r can pair up with negative 8r. They're next to each other anyways. And then 12 can pair up with negative 8. Okay, now I'm going to solve like each of these little problems and see what I get. Right? So, negative 4 plus 6. Is it 10? No. You have a negative. Think of your t-table. Negative side, positive side. Different sides means what? Subtract. You have more positives, right? Okay, over here, 7 minus 8. Negative 1. Good. And then over here, 12 minus 8. What kind of 4? Okay, so put plus 4 then. All right. Now, remember how when we were learning about fractions, like the mathematically preferred way to put the negative in the fraction was not in the bottom, it was in the top, right? Or in the side. And we learned it's not wrong if it's in the bottom, but it's not really preferred. Do you guys remember? Okay, same thing here. This answer isn't wrong, but when I get 1 as my coefficient, remember, all this 1 is doing is multiplying by r. What's 1 times r? R itself, right? So mathematicians are like, oh, we don't really even need the 1 there, so this is how they write the answer. They omit the 1 because it's like unnecessary, okay? This is not wrong. This is just mathematically preferred. Does that make sense to you guys? Whenever you see a variable without a coefficient, it means the coefficient is 1, okay? Does that make sense there? So this would be how your answer should be written, okay? All right, can I give you guys another one to try? Okay, I need to flip my page. Are you guys good with that? Does everyone have this written down? Okay. All right, so here's the other one I wanted you guys to try. Okay, I'll give you guys a minute to see if you can figure that one out. On this one, you've got some things that are the same kinds. You've got some with 2 variables, right? M's and N's. We can put those ones together, right? So we can put together 12mn minus 10mn. What'd you guys get when you put these together? 2mn, right? Okay, now, the other ones we can put together is this one and this one. Okay, everything in front of this 8 goes with this term. So what does this negative negative or minus a negative really make? Positive. So when I rewrite this one, the 7m is easy because it just has a positive, but this is going to rewrite also with a positive. So what do you get when you put that together? 15. What sign? Positive or negative? Okay. Now, do you get to put these together in the end? No, right? This is the answer, this whole thing, right? It's not pretty, but that's the answer, okay? How many of you got that? Good job. Okay, now, I'm going to give you one last one. I think this is the easiest one, but like students in the other classes were getting confused on this type of problem on the homework. So give that one a try. So on this problem, Aren't they all like terms?
Yes.
Yeah, so all we're really doing is figuring out like what we get in our calculation. Okay? So for this first part, you can combine these. What's 13 take away 12?
1.
Okay, 1p. Then this double sign rewrites to what? Negative 20p. So what's 1 minus 20? Yeah. Okay, and this is the final answer. Okay. The only time when you're going to get your final answer as one term is when you started with all like terms. Okay? All right, are there any questions? Okay.